Hi, welcome to my YouTube channel. Today I'm going to tell you about how to define meshing. Most of you guys have faced issue on that. After watching my video, I guess I will clear your all doubts regarding meshing. So the topic is how to define mesh. So continuing with my slide, in like after completing the slide, I will show you the simulation part also, like how to see the meshing and how to do in the simulations. So for like theory part, I am doing with the slides, and for practical part, I will do it with the paint and the ticket simulation software. So now Atlas uses triangular mesh because it is find that it yields much better results. So in Atlas, all the mesh are in the form of triangle. You will see when I will show you in the simulation. So why triangular mesh it prefer? Why not other like rectangular mesh? Why not it prefer? So there's a two reason. The first reason is that it provides better accuracy. So you know that you need a better accuracy with a number of points where the calculation is less. The triangular is the better one for this. So one more thing, it is a one of the crucial, I think, region is like when you going from small triangle to a large triangle. It means that when you are going with the small spacing, like you know that mass have a spacing from small spacing like 0.00001 to some larger spacing like 1 or 10, like it will go so in a transition in a small triangle, then other little bigger, little bigger, little bigger, and it goes like that. So it will be better in case of triangular one. So that is the reasons. And now before proceeding, before showing you simulation, I will tell you some more thing what to prefer, fine mesh and coarse mesh. This is the some of the question you always get, like what I will do, like defining the spacing either as a very small or very large or like in a mid, what I will prefer. So it depends on you, right? Like if you have want to a better accuracy, go with the fine mesh, and if you want faster simulation, so you will go with the course. But like with the fine mesh, there is a like cons, and with the coarse mesh there is a cons. Like as I told you, right, there is a accuracy error, and maybe you will find that your simulation is not better. Like while simulating TFAT, like if you have not a fine mesh, then you will get the tunneling grunt is not proper or something error is you will find. And like with the fine mesh you will like if you have done very fine mesh like in the area, so you will may find that it will take a longer time, and also you will like your simulation will easily get the error name as memory allocation failure because of like very fine mesh. So people what they prefer is the region where they need fine mesh, they define with the fine mesh. The region where they don't need the fine mesh, they define with the coarse mesh. Like air, why you need to be defined in a fine way? It is not required, right? Like air is not the point where the all the calculation is going on. So like preferred like in the air you will do with a coarse mesh, and like region where the device is there do with the fine mesh also. Like I have explained you in some video, right, in the material section, and I think there I have tell you, or in a region one I have tell you, right, that in case of conductor or in case of electrode, what happens is the points at the top or at the last will only, the simulation software will only consider that points. If you define other points in the mid or in the side other than the edges one, it will be not very helpful, right, in the calculation. It will like consumes more memory because there is no calculation going on there, or there is no required calculation. Mm. So after like telling about that fine mesh and coarse mesh, I will show you the simulations part. So how to do the coding part in the simulation. So like most of you guys are familiar already, but some of the beginners may require this to explain. So I will explain them. Like it is a like mesh space dot mult. So it is a multiplication factor, and it defaultly is 1. So why it required, I will show you that also, like what happens if you make it less than 1 and what happens it make you if you make it greater than 1. So after that, you know that the meshing is x dot mesh location and spacing. So you define like that, and similarly for y meshing, you define the location and spacing. So x mesh is generally like it's a vertical one, not a generally like x mesh is a vertical one, and y mesh is a horizontal one. So you will find that lines in a green lines in while when I will show you. So after that, there is some points where you don't need to you want not be messing there. So you can do it with the help of eliminate statement. So like it is a crucial one. Like most of the simulation, I am not finding this eliminate, but it is a one of the crucial way to define the eliminating the messing where you don't need. So other than that, I will explain you one more thing, a mess auto one. One more thing I will add in the eliminate one is that like in air, as I told you, you don't need messing, so you can remove that in a form of rectangle. That area you don't need, that messing area you don't need, so you eliminate columns and you define the rectangle. It's a, like a, you know that x mean x max, y mean y max is representing a rectangle. And other thing is mesh auto, and like it is used when you don't have to define the y mesh. So like you define only the x mesh, and after that the region statement will help you to define the y mesh. But there is like you have to define some more things there. If you don't define, it is not the issue, but if, you have to define some uh, ny and nx there. No, sorry, not nx. You have to define ny only. So ny will give the number of meshing line there. So this is all about meshing, and I will show you some simulation part in coding also. But here I just show you some like meshing. So how it be a rectangular one. So see, here you can see that rectangle, right? Here you can see that rectangles, right? This is rectangles, 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 rectangles. So all are these points are node points, right? These all points where the all the calculation are happens. These all points where the required calculation is happening. So like here you can see that there's a fine here, and here you can see that there's a fine here, and all other are the random one. Okay, it is a random solutions, like as I show you ABC, some random name and other things. But I just want to show you that how the meshing is there. So see, like if this is a our my important area, so what I will define the meshing here fine. So like how you think like it is an important one, like air is not an important one, right? So you can define air as a like normal one. Conductor is not a very much important point, so you can define the top and bottom one. So like that. So here you can see that like here is a fine meshing, here is a like other is a coarser meshing. So as I told you, it depends on where you have want to define the fine mesh, and it where you want to be better calculation. So the reason behind that, why you have to define the meshing fine at the edges, or you can say junction area, is the two reason I will say you that, like while going from here to here, you will find that there is a change in electric field, potential, and doping. So there is abrupt change in potential, abrupt change in doping. So other things also which is related with this only, potential doping. So that is required to be need to be more calculative, like they need to be more precise. So while going from one edge to other edge, or if we can say one junction to other junction, you have to define, try to define in a fine mesh, and other all other area as a little bit coarser. You will prefer it to be coarser. You, if you want to find, it is okay if it is not showing you memory allocation failure. But if you can define other areas, a normal, less fine or coarser one, it's okay. But try to define the edges as a finer one. Okay, like this one. Here I have not defined that fine one, but you can define it fine if you think it required. So one more thing I have like forget to tell you. This is a x1, 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 x1. So you can count it this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like this is depends on spacing, right? I have defined the spacing. This is a spacing. Like the spacing I have defined. This is a spacing. This is a spacing, mesh spacing. Okay, and this is the location. Location is you can define that x location 0 to 1, or I have defined like 2 to this point the location. Here I have defined like this one like this location to this location. So it depends on where you define that locations, and this is a spacings, right? Similarly in the y1 this is a spacing, right? And this is the location. Location is the point where you where it located, right? So after all this, I'm going to tell you in the simulation, like this simulation, where I have defined this structure in the simulation, how I define. Okay. Hi, here I will show you simulation part. But one apology from my side that I have mistakenly says triangle as a rectangle in like 7 minute 15 second around in the video. So you can like correct it. Okay. So, like starting with the the coding and some coding part where I will just showing you how I have done the meshing. Okay, here like which shown you in the paint. Okay, so see like go atlas and then mesh space dot mult equal to 1. As I told you, right, you can make it less than 1 or more like greater than 1, not negative and not 0. Okay, so and then there is a xmas and then there is a xmas like similarly I have defined like how I define I will tell you like it is some random one I just want to be make the messing for x as a constant, so I have just put a value of 0.05 I will show you that how it look like. And similarly I have done for y mess and like the points where I think it is not required that much attention, so I have added it in a coarser one, and where it is need to be more attention for the simulation it is in a fine one. So as I told you in the previous videos, right, like there's a node points is there, so where all the calculation is going on, that it you will see while when I will simulate this one, what is node points and how much node points it is there, I will show you. So I'm running the simulation. This can you can ignore, it is not the issue. You can see my this window. Yeah. So see one more thing, like this is some random simulation as I will tell you also. This is some random one, like some random things I have defined. So for showing you purpose how is meshing is defined. So see one more thing, like there is a total grid points as a 2814 and the total triangles as a 5320. So like Atlas have a some limitation that like you can't define much number of grid points. Like there's I think for 2D it is 20,000, but you have to be taken care that you will define number of node points or grid points little lesser than that. And for like 3D it is 2 lakh and 4 lakh. So try to make it lesser than that the grid points. Okay, and so I will show you the meshing. Like as I already shown you there, like this is a meshing. I will show you avoid this one. Yeah, this is something like that. What I've done is I have made the device mid device as a my like you can define it mid device as a like where all the I think for me it is the calculation is going on or all the thing is there. So I have defined that as a very fine one and another one as a little bit coarser one. So it is you can see that there's a triangle is there, which is you can see that is smooth here or smooth here. Okay. One more thing, there's a command name is a smooth, so you can define as a smooth equal to 4. Whenever you think that it is little bit like triangle getting more not smooth, it is like it is not a smooth one. For like smooth transition is not there, you can define the smooth and its value like 4, 10 and whatever it is, you will find that the now the meshing will become little bit smooth, not like abrupt one. Okay, and as I told you, right, there's a when you go from one layer to other layer, there may be the abrupt change in potential and doping concentration, and that will lead to change in electrical and other things there, like it will changes. So for calculation purpose, we need more finer points at that edges where the layers are changing. So like there, we will prefer little bit more fine meshing as compared to inner layers where we need, if it is not a fine one, it will okay. So what I had taken care while I am defining the meshing for my simulations. So one more thing I will tell you, like if you are a beginner, it is okay that you will not find that messing in a one go. You will little bit learning in a like acquire the knowledge in a first you define, you will go with the hit and trial methods, like this will hit or not, this will hit or not. So you will get to know, oh, it is not good. It is not a good, it is not a bad. So you understand that afterwards when you do the two three try with the two three points, how it works or how it will not work. So it will like help you to get that which messing is better, which messing is not better for your simulations. Like for me also, right? Sometimes I have to do, like I have to edit my messing for a number of times. Like, oh, it is not fitting better. It is not fitting. Like I don't have any formula for that. You define like this. You don't need to do anything. I have also to do like hit and trial there. Okay, so you have to also. Yeah. Then I will show you the like what happens when it is defined with like space dot melt as a lesser than 1, 0.5. Okay, so now you see that I have not off that one. It will run in a minute. Here you will not find the memory location failure because here you will not find, because here the simulation is not running. Where the solve statement is come, there will you will find that, see that number of grid points increases. So that means the number of grid points increase because of number of like I have defined that the spacing between that two meshing is it have a multiplication factor of 1. Now it is 0.5. So now the spacing between the two mesh, particular mesh, have a multiplication factor of 0.5. Okay, so this is like you can see the see that like how it is different one. And similarly, if I go with a 2, you can see that one also. So you can see that till that time it is running. So you can see that like it is a multiplication factor of the spacing, the two spacings, right? So it multiplied by that factor. And now you see this. Yeah, see this. It is a little bit, you can see that you can contrast that, right? Now it is multiplied by that factor. So it is one of the good things, I guess. You can define the meshing in a better way with that mesh space dot multi equal to 1. But if you like forget to add that thing, it is not the issue because it defaultly take 1. Okay, so it is not the issue. You define better in the X mesh and Y mesh 1. So yeah, that is the things. And like one more thing, like as I told you, you can define a mesh auto and do that with the region, but like I will not show you proper one, like, and as I explained in the video, right, ny equal to something is you have to define. So but I will show you here also, like you can define this as like this also. Like see, you can compare the result of the previous one and this one. See the result. Yeah. Yeah, it's almost same, right? Because mesh auto, it will not take auto as because here I have already defined the y mesh. So it is yeah, it is not taking it. But see, something is happen here. Like you will find that it is not there on that one. Here you can see that here the meshing is a fine in the bottom one, right? Like there is abruptness in that one, but here the abruptness is lesser here. So you will find the changes there, like these things. Like here, there's abruptness in that previous one, as I can see, and you can also see when you take see that carefully. Like this portion, there's abruptness in there, with the mesh auto it is not there. So like I guess it is a better one as compared to mesh page.mult for this values, because here the meshing is smooth, but it will not affect that much. Yeah. So like if I don't define this one, what happens? I will see. Let's see, you have already seen that, and you can reverse it and you can check it whether it is how it will change or not. See, it will also do the like it will also not show the errors, but you can see that this one. See, it is not like what you expecting, right? It is also run the simulation. It is a coarser one, right? So for to avoid that, as I will already tell you, you have to define ny and define it using like a thickness one, not like coordinates one. Okay, so this is the second way to define the meshing, but priority should be defined like X mesh and Y mesh, and mesh auto is also one of the way you can define. And yeah, some one more thing is mesh like smooth. As I told you, right, smooth is there. You can use the smooth to make the like this abruptness smooth one. And one last thing, like there's a one more thing is regrid. Regrid also you can use to make the meshing fine. I will explain you that in a further videos because it is become very longer. So yeah, this is and if you find like something mistakes in my explanation, you can tell me in the comments, and also please if you have a doubt, you can ask me in a comment box. Okay, bye.